In this video, we will be discussing solar installations at FIU's engineering campus and a proposal for a similar installation at FIU's main campus. A collection of solar cells placed on a large area in order to collect sun rays are referred to as solar panels. Their purpose is to collect light, which is then turned into electricity. In a solar panel, there are two layers of silicone crystals. The top layer has unstable electrons and the bottom layer is electron deficient. As the sun hits the top layer, the movement of electrons from the top to bottom layer generates energy. This energy, however, comes in the form of direct current and must be turned into alternating current in order to be compatible with residential and commercial appliances. This is done through the handy-dandy external converter. Behind this is a solar panel installation at FIU's engineering campus. This installation has 4,400 panels, a project that took approximately 4 months to come together. In order to get the most amount of rays, every factor must be taken into consideration. Take for instance the sun's tilt. The Earth is tilted at 23.5 degrees. Therefore, the ideal scenario would be for the panels to also be tilted 23.5 degrees in order to get the maximum sunlight consumption. Another factor to take into consideration is the position the panels face. South is the best position, taking advantage of the sun overhead. Other models tilt in order to take advantage of the full sunlight throughout the day, however these behind us are still. The campus itself is not using the energy that they generate, as FIU is partitioning with FPL and the energy itself is being fed back into FPL, better known as the grid, with an average production of 1.4 megawatts a day. The average solar panel tends to be cost-effective after 15 to 18 years. The biggest problem, of course, is the money required up front. However, there are plenty of incentives put into play, some even helping with up to 30% of the cost in residential and commercial properties. FIU Engineering Building is across from the main campus, which does not have solar panels. Let's head on over to the main campus and see what plan we can come up with in order to get the main campus on board. We are proposing a solar panel canopy on the 6th floor of the rooftop of PG6. The size of the installation of these solar panels would be 108,000 square feet. That gives us 2,596 panels that will be tilted at exactly 23.5. It would cost about $600,000 for the panels and roughly $600,000 to install them as well. Altogether, it would be nearly $1 million. That's a saving of $165,000 a year. The size of these panels will be measuring 3.25 feet by 6.4 feet, which will give us an area of 20.8 square foot per panel. Each panel will cost $228 and will generate 315 watts, while the average solar panel generates 280 watts. These panels will produce 5.8 megawatts a day, and in a year, they will produce 2,117 megawatts of energy. We can fund this project by incentives, loans, and a slight increase in parking fees. If we would increase the parking permits by just $5 a year, we could generate the profit of $272,000, and FIU would save $164,000 a year. FIU can also qualify for rebates, a first rebate of $100,000. Then we can simply take out a loan of $1.2 million that would be paid off in 2.9 years after the yearly deductions of the generated profit and the money saved by the solar panels generated. That's not bad compared to the benefits of clean energy.